Hi, we are here at the South Whidbey School Farm, and we want to share with you our marvelous new solar panels on our new outdoor classroom. We wanted to be able to capture the sun and convert it into electricity so that we could grow the thousands of starts we need every year for our farm and to distribute to our school families growing gardens at home. So here is how our solar panels work. The sun is sending energy to the earth from 93 million miles away in the form of tiny particles called photons. Did you know that plants use photons? That's what their leaves are for. They capture photon energy, light energy, and through a process called photosynthesis, they convert it to nutrients for the plant. Without that energy from the sun, plants couldn't live. Now, solar panels capture photon energy and convert it to electricity through a process called the photovoltaic effect. Each of our solar panels is made up of dozens of solar cells, each of which contain layers of silicon. When light hits a cell, electrons in the silicon get excited and generate a small electric current. When you put them all together and then add them to a whole array of solar panels, you get enough electricity to power the lights that grow our starts. Now, the most important thing if you want to install solar panels is to make sure you're going to have enough sun, right? So this is a south-facing roof, and we have the sun that arcs over the sky right there. So we called up Whidbey Sun and Wind and asked them to do a site assessment to see if we put our solar panels up there, are we going to get enough sun to generate enough electricity to make it worth the cost and the time and the investment in the solar panels. Paul Dickerson at Whidbey Sun and Wind calculated that we needed 10 panels to give us the power we need. To install the solar panels, you start by attaching clips to the roof. Then, rails are attached to the clips.
This system is going to use microinverters. This is a small inverter that is paired with one solar panel. It converts the DC energy that the solar panel produces into AC energy.
DC, or direct current, is the type of power that comes from a solar panel. It's the same kind a battery has. But to work with the grow lights we have and just about everything else that uses electricity, computers, televisions, microwave ovens, you need AC, or alternating current. And that's what the inverters do. They convert DC to AC.
There's 10 of these units that are installed that are all connected together in parallel through this cable, and that gets routed down to the electrical panel below the roof. This system operates at 240 volts, just like the voltage that's present in most houses. That has what we call two hot legs and a neutral, as well as a ground wire. The conductors that are passing through these conduits here, you can see, for instance, through this one, you can see a red wire and a black wire and a white wire. Those are the wires of the circuit. The green wire is for safety, and that if there's ever a short circuit with anything, that allows the system to turn off safely.
And then one by one, the solar panels are attached to the rails. Then the electricity runs into the grid and is used by the nearest devices needing it. The lights in our outdoor classroom and the lights growing our plants. So when I turn this light on, these plants are now getting energy from the sun to grow.